Have you ever pondered the impact of heavy metals on our environment and health? Does the term Minamata disease ring a bell? To jog your memory, Minamata disease was a disastrous neurological syndrome caused by severe mercury poisoning. The outbreak occurred in 1956 and re-emerged in 1965, affecting communities around Minamata Bay in Japan, who consumed fish and shellfish contaminated with methyl mercury. This disaster was a stark reminder of the destructive potential of heavy metals in our ecosystem. Heavy metals are often introduced into our environment through industrial activities and sewage water. Despite efficient sewage treatment, trace amounts of these metals inevitably find their way into our terrestrial and aquatic ecosystems, leading to phenomena such as eutrophication and biomagnification. This contamination disrupts the balance of our natural water bodies, posing a threat to the organisms within and ultimately to us, the consumers. This is where phytoremediation comes into play. Phytoremediation is a powerful tool that harnesses the natural abilities of plants to clean up our environment. Think of it as using nature to combat the harm caused by human activities. By incorporating this method into our waste treatment strategies, we can enhance the recovery of even trace amounts of toxic heavy metals from wastewaters before their disposal. In a recent research study, an interdisciplinary approach was adopted to investigate the uptake, biotransfer, biomagnification, and bioelimination processes operative in well-phytoremediated sewage water. The study was divided into two parts. In the first part, 2 experiments were conducted to phytoremediate sewage water through semi-hydroponics with varying numbers of macrophytes and hydraulic retention time. Over a period of 150 days, arsenic, mercury, and cadmium were successfully reduced below detection limits. Additionally, more than 90% of nickel and lead were also remediated. The second part of the study focused on the recovery and detection of these 5 heavy metals through the processes of uptake, accumulation, biotransfer, and biomagnification in tritrophic aquatic and terrestrial food chains. The concentrations of these heavy metals in food chain organisms were determined with EDX spectroscopy, a method more sensitive than the commonly used ICP-MS. The implications of this research are profound. By highlighting the effectiveness of phytoremediation, it paves the way for more widespread adoption of this method, which could significantly reduce heavy metal pollution in our environment. It also underscores the need for ongoing research in this area to protect our ecosystems and ultimately our health.